you'll be able to use elimination in order to solve systems of linear equations. So here is our system of linear equations. Negative 21 equals 3x minus 9y. And then we have, for our second equation, negative 4y minus 12 equals negative 4x. And the first thing we need to do is we need to line them up. Line up the terms. We need to get x plus y equals some number. So we can see that our first equation, the x and y's are already on the same side, already on one side. We have 3x plus negative 9y equals negative 21. So we can leave that first equation alone, and it's just a matter of rearranging that second equation. But it's kind of unclear what goes where. So what we will do is we will rewrite negative 21 equals 3x minus 9y, and we're going to line up our equal signs. Now, on the left side of the equal sign, our bottom equation, we have a negative 4y minus 12. So let's write that on here, negative 4y minus 12. Okay. And on the right side of the equal sign, we have a negative 4x. And now the picture is starting to get a little bit clearer now that we lined up our equal signs. Our x's are lined up, so I can leave this x alone. Even my constants, they look like they're lined up, okay? But I have this negative 4y all the way over here on the other side, and it looks like I need to move this across the equal sign over here. So how do I move that negative 4y across? If I have negative 4y minus 12 equals negative 4x. I want to move that negative 4y across. So what I do is I just add 4y to both sides. Plus 4y plus 4y. That way this will cancel, and now I'm left with negative 12 equals, and now since I have, okay, I have a negative 4x. Negative 4x plus 4y. And there we go. So as I rewrite this, negative 21 equals 3x minus 9y. My bottom equation now looks like negative 12 equals negative 4x plus 4y. There we go. Our terms are lined up. So I have my x's, my y's lined up equal a constant. So we lined up the terms. Now the next step, pick a variable and get a common multiple. So let's pick a variable. We can either pick y or x. Which one do we want to eliminate? Well, I know the common multiple between 3 and 4 is 12. 12 is a smaller number than the common multiple between 9 and 4, which is, what, 36? Let's choose to eliminate x. If you want to, you can choose to eliminate y and use 36 as a common multiple. But in this video, I'm going to choose the x, and I'm going to use 12 as my common multiple. So if 12 is my common multiple, because I know that 3 goes into 12 4 times, and I know that 4 divides evenly into 12. So I'm going to use 12 as my common multiple. The next step is I need to multiply the equations by the right factors. So if I want to get 12, I want this 3x to say 12x. 3x times what will give me 12? Well, I know that 3 times 4 is 12, so I need to take this 3x and multiply it by 4 so that I can get 12. But I can't just multiply 3x. If I multiply the 3x, I have to multiply the entire equation. So I'll take my entire equation and multiply it by 4. Same thing for the bottom. I have 4x. I want to get a common multiple of 12. 4 times what equals 12? 4 times 3. So I multiply my entire bottom equation by 3. So let's rewrite negative 21 times 4. That's going to be 24, 60, 80, negative 84 equals, now 3x times 4 is 12x. Negative 9y times 4 is 36y minus 36y. Oops. Something went wrong. Alright, there we go. Okay, and we're back. Okay, equals 36y. Negative 36y. Now I'm going to take my bottom equation, multiply it by 3. Negative 12 times 3 is negative 36. Equals, now negative 4x times 3, that is going to be negative 12x. And 4y times 3 is going to be 12y plus 12y. And there it is. We multiply the equations by the right factors. Now, in order to eliminate, we want to add up the equations. We want to add up the equations such that one of the variables cancels out. And in order to do that, we need to multiply an equation by negative 1. Now, we said we wanted to eliminate the x. I have a 12x and I have a negative 12x. This step's already done for us. One equation is already multiplied by negative 1 because this negative 12 is automatically going to cancel out that 12 when we add up the equations. So we're good with this. Now we can just go ahead and work with adding up the equations. Negative 84 plus 36 is going to be equal to negative 84 plus negative 36. It's the same as saying negative 84 minus 36. It's going to be negative 120. Negative 120 equals 12 and negative 12 cancel out. So 12x minus 12x is 0. And now negative 36y plus 12y, that is equal to negative 24y. So I have successfully added up the equations. And as you can see, my x was eliminated. Eliminated the x. Now I want to solve for the remaining variable. I'm going to solve for the remaining variable. So now I have this y. I need to solve for y. How am I going to solve for that y? Divide both sides by negative 24. And once I do that, y equals negative 120 divided by negative 24, which evaluates to 5. So y equals 5. So now we know that y equals 5. We have solved for y. Now I want to substitute this 5 into one of the original equations. So my original equation was up here, and now that I know that y equals 5, I can just plug that 5 into the original equation, and I can solve for the other variable. So if y equals 5, then what I'm going to say is, as I rewrite this one, negative 4 times, and now remember y equals 5, so that's going to be substituted into there. Negative 4 times 5, then we finish writing it, minus 12 equals negative 4x, and negative 4 times 5 is negative 20. Negative 20 minus 12 is equal to negative 4x. And now I'm just solving for x. That's my last step. Solve for the other variable. Negative 20 minus 12, negative 32 equals negative 4x. Divide both sides by negative 4. And x equals negative 32 over negative 4, which is positive 8. X equals 8. So the solution to our system of linear equations is 8 and 5. And this is the point where our two lines intersect.